So good morning, everyone, and welcome to this third session of Space for Critical Infrastructure. This is actually the last webinar of the introductory part. So my name is Cornel Bogaert. I will host this session. And I work for Eurizi, which is a non-profit association based in Paris, and we aim to promote satellite applications. And throughout this series, we aim to do this specifically for the monitoring and maintenance of critical infrastructure. So if you have been following the series already a bit, you know that we follow the proposed directive on the resilience of critical entities, which aims to set up an all hazards EU framework that supports the member states in their national efforts to ensure that critical entities are able to recover, but also absorb and resist disruptive incidents. And this can be all inclusive. So this is natural hazards, this is accidents, terrorism, all kinds of threats and health emergencies, for instance. And so the webinar series, it's organized together with our partner Nereus. So maybe Margarita, if you would like to say a few
Yes.
words, please go ahead.
Thank you, Cornel. So it's our pleasure to organize these webinars jointly with Eurizi. Nereus is the network of European regions using space technologies. We represent the interests of European regions, and we explore and promote the use of space and the benefits of space technologies for European regions and their citizens. Wish you a great and fruitful webinar, and the floor is back to you, Cornel. Thank you.
Thank you very much, Margarita. And so let's jump in right away. So, I mean, just first, I would like to also say that everyone can, if there are any questions, just write them down in the chat. We will try to answer all the questions after the presentations. And just also as a general reminder, so the overall objective behind the series is really to sensitize the added value of space-based assets and applications to address the monitoring and safeguarding of critical entities. And so today we have with us Philip Mosley from the European Commission to share some opportunities and views for the green and digital transition in the construction sector. So Philip Mosley, you can now share your screen and you have the floor now.
Okay, thanks very much. Nice to meet you all. And I'll just share my PowerPoint, and I'll put it on full screen. Can you see the correct slides there, or is it maybe I need to?
Yes, we can see the slides, but it's not yet in presentation mode.
Like that?
No, it's still in the overview.
Okay, I'll share the PowerPoint instead of the screen then. And it's going to be that.
Yes, now it works. Perfect.
Okay, great. So yes, my name's Philip Mosley. I work in the construction unit in DG CRO, the Directorate General for Internal Market, Industry, Entrepreneurship and SMEs in the European Commission. And there I'm responsible for policies to do with the green transition of construction, as we now call it. We're working on this thing called a transition pathway, where we have the green and digital transitions working together, and I work on the green part, which in practice that means everything to do with circular economy, resource efficiency, and also energy and energy efficiency in buildings. But also infrastructure, of course, when it comes to circular economy. Right, I will move to my next slide. So when we talk about construction, the construction industry, we have the industry ecosystem. And what this is it's coming out of the EU industrial strategy. It defines 14 industrial ecosystems, and construction is one of them. The ecosystem is a broader way of looking at the industry. So beyond just what we would normally call the sector, and the ecosystem is the whole, wider kind of supply chains and other stakeholders involved. So in the sense of construction, it's not only the industry itself, but also some of the public authorities, for example, that are involved in permit processes and that kind of thing. So the gross value added of the ecosystem is big. It's almost 10% of the EU gross value added. You can see there are millions of jobs, 5 million firms working in construction. Of course, the vast majority of them are, are SMEs or even micro enterprises. And then we have the environmental impact of construction. So it's the biggest single source of waste generated in the EU with over a third. It uses around half of all resources extracted in the EU are destined for construction. And of course, construction is also responsible for greenhouse gas emissions, and the buildings that are constructed also consume energy. So it has a big impact. So as I mentioned, this transition pathway is what we're working on right now, as coming from this industrial strategy. So what we've been doing for some months now, we've been working on this document. We started with a staff working document that was published in December. And what that did was it set out scenarios for the transition to be green, digital and resilient. Scenarios by 2030. So it set out basically a series of actions. And that was consulted on. It was open for public consultation. We had more than 100 responses. We also presented it in various fora. But the main way that we consult with the industry and with the member states as well is through the high-level construction forum. And we've been holding now more detailed thematic discussions on various themes to do with this transition. And we're aiming to produce the transition pathway document towards the end of this year. And what that will do will be set out a series of further actions that need to be taken by the Commission, recommendations for member state action, and also recommendations for industry action. When it comes to circularity and circular economy in construction, there's a lot going on in different areas. So what we have here on the slide are the two big strategies on the left and right. So on the left, the Circular Economy Action Plan, and on the right, the Renovation Wave. And under these, there are a series of actions, some of them here. So the ones to do with waste, reducing or revising waste targets, end of waste criteria, and also material recovery targets. These are all relating to studies that are ongoing or maybe in some cases close to finishing, related in some way to the Waste Framework Directive. And the Waste Framework Directive is the main legislation on waste for construction. It has a target. So by 2020, all member states had to divert from landfill at least 70% of their construction demolition waste. But of course, that was a 2020 deadline. So there may be a revision of the directive in future to revisit that and to look at other issues like this. Then we have a roadmap for whole life carbon in buildings, which I will get onto in a moment in a bit more detail, because the whole life carbon is a whole issue in itself, and I will explain that. We have some action on green public procurement. So procurement is a big way in which particularly local level, city level and regions can influence construction because they are in charge of procuring very often for their local area. And on procurement, we also have an initiative at the bottom there called Big Buyers, which is bringing together the major procurers, so major cities, but also national infrastructure procurement bodies. And they are exchanging best practices and also speaking to the industry about what is best practice or what's the best possible that they could then put in their procurement. And the Big Buyers Initiative has a working group on circular construction and another one on zero emission construction sites, among other working groups as well. So I mentioned the whole life cycle of greenhouse gas emissions, and this is a really emerging policy area now. Over the last couple of years, really, this has become quite a high priority. What it basically means is that, particularly for buildings, when you look at the emissions, until recently, we were mainly talking about the energy consumption of buildings. So decarbonizing buildings was thought of as decarbonizing the heating and cooling and the renewable energy that you need on a building. But actually, when you look at the whole life cycle, the construction part and the demolition part, or the end of life, as we call it, at the end of the lifetime, is also generating a lot of greenhouse gas emissions. And we need to be tackling all of it. So construction is a major producer of greenhouse gas emissions. So the way we've been tackling this is, first of all, we have the levels framework, and this is a framework that was developed a couple of years ago with 16 indicators to measure the sustainability performance of buildings. And one of those indicators is global warming potential, which is the greenhouse gas emissions. And this indicator is now making its way into various other policy files as a way of consistently measuring and reporting on the life cycle greenhouse gas emissions of buildings and construction. So we have an ongoing action to develop a roadmap to reduce the life cycle emissions of buildings by 2050. That's coming under the Renovation Wave strategy. We also have now, in the new proposal to revise the Energy Performance of Buildings Directive, we have some elements in there on life cycle emissions to do with the construction of buildings. So we will have a deadline by 2027 for public buildings, and for 2030 for all new buildings. They will have to calculate and declare their life cycle emissions. We also have some elements of this part in the new proposal to revise the Energy Efficiency Directive, and also in the Construction Products Regulation, also under revision. So a lot of these things are being revised at the same time. We're making sure that this issue is coherent across all of them. So in the Construction Products Regulation, one of the provisions in the proposal now is that all construction products will have a mandatory declaration of their carbon footprint, their global warming potential, in other words, so that the data then, which also has to be digitally held for each product in a product passport, will be made available then for designers of buildings and infrastructure to calculate the life cycle emissions of the whole piece. So this is a development, a recent development in sustainable construction. And of course, one of the ways we can address and reduce life cycle emissions is by the circular economy. So reuse and recycling of materials is a way of avoiding generating more emissions by more resource extraction and creating or manufacturing new materials. So I mentioned the Construction Products Regulation. It's under review. It's a very complex piece of legislation. So it hasn't been working very well until now, especially for two aspects. One was the single market for construction products. So it hasn't really been working out where, if you put a construction product on the market in one member state, it's marketable or across the whole single market. There have been various problems with things like standardization, and there's a backlog of standards now. So one of the aims of this revision proposal is to empower the Commission to intervene in the standardization process and clear this backlog. And then also integrating sustainability requirements into construction products. So not only the greenhouse gas emissions I mentioned, but other things like recycled content or other environmental aspects. It will empower the Commission to make product requirements. So, for example, there might be, for certain construction products, a minimum recycled content introduced. Then we have for construction or relevant to construction, a lot of different funding programs. The biggest one of all probably in terms of money is the Recovery and Resilience Facility, which comes under the Next Generation EU banner. And this facility is these numbers you see on the screen. It's the money made available to the member states for rebuilding or investments and reforms coming out of COVID. So to rebuild the economies, if you like. And most of the member states have an element there on building renovation. So that's a major part. But there are also various other aspects relevant to construction in there, things like skills development. So we've been supporting the member states to make sure that when it comes to building renovation, they integrate as far as possible those aspects of circular economy and resource efficiency that I mentioned. And then we also have, of course, other funding programs, notably the Horizon Europe program for research and innovation. This has several different areas relevant in some way to buildings and construction and infrastructure, but I can pick out the two probably most important ones. In Cluster 4, there are some topics in there under a section called A New Way to Build, and that really focuses on the green and digital transition of construction. And in Cluster 5, there's a partnership, a public-private partnership called Built for People, and that is looking across the whole value chain of construction and trying to accelerate deployment of solutions for a sustainable built environment. So that is probably the most important partnership for construction in Horizon Europe. And of course, there are other funding programs doing various things, the cohesion funds. There's also the LIFE program, which is sometimes relevant to construction and so on. And then another important policy area that we've been working on is this EU Finance Taxonomy. And what this is basically harmonizing an EU definition, if you like, or criteria for green investment or sustainable investment. So it's having a common understanding of sustainable activities that then can be investable. And there are already out and published criteria for climate change mitigation and adaptation investments, so including, for example, investments in buildings. But we're now working on the next and last four sets of criteria. So as you see at the bottom there, water, biodiversity, pollution and circular economy, they're being worked on at the moment. And they would define, for example, civil engineering infrastructure, which also contributes to a circular economy. So that's an area of work as well. We have some documents that we published recently. We're continually doing studies. So we have on the right a guidance document on circular economy principles for buildings design. It's aimed at various target groups. It explains the concepts. It sets out a kind of guidance on how to achieve this circular economy. It's also a useful reference document in itself. It was developed with industry and with the member states. And then on the left, with the same title, but a follow-up study that looked at policy options. And that's interesting because it gathered a lot of case studies from across the EU, national policies, but also non-EU countries, OECD countries like Israel, Canada, Japan, I think is in there as well. And it made some policy recommendations for the circular economy in buildings. We also have this guidance document, which is a bit older, and we're looking to update it in the near future, but it's still current, the Construction and Demolition Waste Management Protocol, and it's really a protocol to follow on site of how to manage and sort construction demolition waste, because that is one of the most important things to facilitate a circular economy, is to when a building is demolished, that it is not just smashed up, but all of the different elements are sorted and then categorized for reuse and recycling. That was my last slide. I can just highlight on here our website that's there with information on all of these things I mentioned. And also there's a LinkedIn group if you're interested, the EU construction ecosystem there. So that enables you to keep up to date with what we're doing as well. Thanks a lot, and I'll be happy to answer any questions.
Thank you very much, Flip, for your insightful presentation. I don't see any questions from the chat for now, so just a quick reminder for everyone. So if you have any questions, don't hesitate. Please just use the chat. Maybe, if I may, I can just ask you a quick question. So what do you think now is I mean, just to frame it, because last year we had also another webinar session where we saw, for instance, some regulatory barriers that was done related to the monitoring of pipelines. And so we saw that in some countries, specific monitoring tools, such as the use of satellite data, they were not really recognized. So maybe some similar issues exist in the construction sector. What would you say is the most important or the added value of EU policies in the sector? So yeah, that is the question.
Well, I mean, it depends. The added value of what we try and do, at least in DG Grow, is we always try and harmonize across the single market, because it doesn't make sense to have rules in only one country, especially when it comes to marketing of products or economic activities. So we try and make sure that rules are applicable across the whole single market, and that's what's behind the construction products regulation revision. I think that when it comes to something like monitoring infrastructure, it obviously benefits saving capital investment costs if you can put that money into preventative maintenance, rather than if maintenance issues aren't tackled, then you end up with problems that then require major intervention and major cost. So it definitely makes sense from an economic point of view to maintain infrastructure, but also it actually makes sense from an environmental point of view as well, because the longer we can keep infrastructure in its service life, the better, because it avoids creating new ones. So that this thing of extending the service life is actually, it's an environmental goal as well as an economic one.
Okay, and then so in the meantime, I see that we have some other questions. So first question is coming from Matthew. So interesting comment on the carbon footprinting of construction materials in the forest product sector. I understand there is a great deal of controversy about calculating the CO2 potential. Any thoughts about how this proposal will break that roadblock?
Yeah, that's a good question. So there is indeed a lot of discussion about the relative merits of different materials. So, should we be promoting wood instead of concrete, for example, because concrete generates a lot of greenhouse gases in its manufacturing, or especially from the cement. I think that that's one of the things that this life cycle approach would do, is to give designers the tools to understand the overall impact, the greenhouse gas impact. But when it comes to wood specifically, there's another issue, which is the carbon storage. And the Commission does have plans to produce a certification scheme for carbon storage. So a way of being able to certify how much carbon is stored in a product, in a construction product, for example. So this element of carbon storage is also included in the construction products regulation revision, and but one of the issues is at the moment the standard for life cycle analysis doesn't include this carbon storage element, so it would probably be a standalone separate certification, whereas the overall life cycle analysis would just be for the emissions and not the storage.
Okay, and then maybe one last question. So do some of the various documents you mentioned in your presentation contain provisions related to the use of Earth observation in construction, such as to monitor greenhouse gas emissions?
There's the transition pathway that I mentioned, which is the series of actions that we're looking at. I believe that there is something in there on Earth's observation, the relevance of that. We'll certainly take that into account as we develop it, because I think it is relevant, especially for some of the challenges we're facing with resilience. I mean, just to give you an example now, we have the war in Ukraine, where President von der Leyen has already mentioned that she wants the European Union to be heavily involved in the reconstruction. And although the war is still ongoing, of course, we're already starting to think about the reconstruction. And I know that there is precedent for using space data to help with reconstruction, as was done in Italy after the earthquakes there. So that is a possible area as well to keep an eye on.
Okay, so perfect. Thank you very much, Philip. So now I think we can give the floor to our second speaker. So now we will have a presentation from Raffaele Santangelo. So now it's about a national project which is called 1000 Infrastrutture, which is a network of 80 enterprises to monitor the stability and infrastructure. So in Italy. And I suggest, Raffaele, you take the floor now. And if you're ready for your presentation and to share the screen, please go ahead.
Morning. Are you able to see my screen?
Yes, perfect. You're good to go.
Okay, thank you so much. My name is Raffaele Santangelo. I'm the Deputy Program Manager of the 1000 Infrastrutture Enterprises Network, which I will briefly present during my speech. Thanks to the organizers for the invitation to participate in this interesting webinar. The Italian infrastructural road network has a total length of about 800,000 kilometers, of which the main highways and regional roads represent only 4%. On this limited portion of the network, the number of bridges, viaducts, and overpasses is about 28,000 units, and the tunnels are about 2,000 units. Each engineering work must be considered as a case due to the constructive peculiarities, the state of degradation, and the hydrological context where it is located. The useful life of infrastructural components manufactured with concrete is approximately 50 years. Here in Italy, most of them were built between 60s and 80s, and therefore they need to be monitored. The Italian infrastructure, road and railway works are estimated at just under 2 million units, of which only 3% are currently monitored. This number is so relevant due to geological, morphological, and geographical characteristics of Italian territory that is also naturally predisposed to instability phenomena such as landslides and floods, and there's also high seismicity. In 2019, on the 14th of August, a dramatic event shocked political board, road managers, and public opinion, not only at national level. The collapse of the Genoa Bridge, which caused the death of 43 people and displacement of about 600 people, highlighted the need to intervene on the method, effectiveness, and responsibilities of infrastructure monitoring system. In the last 5 years, the Italian Ministry of Infrastructure has focused its attention on the drafting and publication of technical regulation aimed at improving the methodologies of static and dynamic monitoring of infrastructure. In the 2021, the guidelines for classification and management of risk, safety assessment and monitoring of existing bridges of highway, national, provincial and metropolitan roads were updated. And the main objectives are the uniformity of risk assessment criteria, the adoption of a single line of attention for all risk, and field testing of guidelines to verify the actual increase in safety level. Similarly, in this year, the publication of guidelines for the monitoring of tunnels is expected. Finally, the Ministry has introduced laws and technical standards that require the use to the design company of carry out of technical economical feasibility project of public works using building information modeling solution. The main purpose is to create an open digital database for work with high alert level to gradually achieve the full digitalization of infrastructure network. The definition of an effective monitoring system is important to solve problems such as the long time scales for risk classification, the management of design and construction defects, the lack of funding and very long approval and construction times, the increasing also of insurance costs. The innovative monitoring proposed by the Enterprises Network introduces significant benefits in the dynamic verification of the state of infrastructure in different phases of their life, starting from construction during the use of road networks and also in periods of ordinary and extraordinary maintenance. After a year of work, which began in August of 2020, when the regional technological district of Basilicata and Liguria, named Ternensit, presented to the Italian government the first project sheet on the innovative monitoring of infrastructure to request funds from the Next Generation EU program. On the 16th of July of 2021, the Enterprises Network Mille Infrastrutture was officially established with the aim of innovating the methods of static and dynamic infrastructure monitoring. At this time, the network is composed of 78 companies, consortia and district, from spin-off startups, small and mediums, to large companies, highly innovative products realities aggregated with the universities and research institutes of national and international renown. Mille Infrastrutture represents the largest Italian national network of enterprises, an excellent technological interlocutor to address and solve every complex problem of control and monitoring of the national road and rail network. The network provides to its top-level structural engineers the collaboration by the best experts in innovative technologies, from satellite to multi-sensor drones, from varied types of sensor to the artificial intelligence application, with the final aim of implementing a secure IT platform to ensure the protection of national critical infrastructure. A network of complementary skill that sees the major national player in the field of technological innovation as protagonist, and which guarantees a national geographical coverage, thus enable cohesion between the various areas of the country, from south to north. In addition to the main regional technological district, there were the promoters of the initiative, together with the Italian Institute of Technology in Genoa and the Scuola Superiore Sant'Anna in Pisa. The network includes the Fabre, Eusenter, and Stret Engineering Consortia, large international companies such as Leonardo, Telespazio, Geos, Engineering, Santer Reply, over 50 small and medium enterprises, and through special collaboration agreement, over 50 university and research centers. In our vision, the monitoring is not limited to installing and collecting data from sensors, but involves a complex management chain that includes communication, data center, analysis and decision support algorithms at national level. In full compliance with the regulation, the network with its associates can design technological solutions capable of responding to the complexity of the requirement. The main objectives are the analysis and classification of engineering work that need to be monitored to identify type and number of sensors, the definition of system requirement of the monitoring system, the design and development of the IT monitoring platform, including the data population, analysis and monitoring in compliance with guidelines, and the dynamic extension of coverage and follow-up for analysis to ensure continuous system refinement. The enterprise network is implementing an innovative IT platform for monitoring infrastructure that are not considered as isolated elements but are evaluated as an integrated system with the territory in which they are located. Traditional and innovative sensing technologies are integrated to ensure reliable and accurate measurement of the behavior of the infrastructure and territory system. The integration within the monitoring platform of the most innovative technologies for data analysis, processing, verification, and validation makes the system effective and fast in management of large amount of data. A central role of the system is represented by the stakeholder, who express the demand and at the same time validate the effectiveness of the decision support system. Mille Infrastrutture has 400 experts who provide their contribution in 5 technical tables. The first table is dedicated to the study and analysis by structural engineers and technicians who know the technical regulation to be applied for the monitoring. The whole of the second, third, and fourth technical tables represents the innovative component proposed by the enterprises network, respectively in the field of sensor, data processing, analysis, and IT platform. The fifth technical table is the place of confrontation between structural technician, expert in innovative technologies, and stakeholder. In this section of presentation, I will highlight how Mille Infrastrutture considers the application of advanced differential interferometric SAR techniques in order to monitor the territory and road infrastructure to be very relevant. Since 2000, some companies of the network have successfully analyzed with this satellite technique various case studies. The output of some projects developed by Geocard company are shown in these images. The slow movement of the urban site, area affected by subsidence phenomena, and bridge and other engineering work have been analyzed. The use of these satellite technologies make possible to quickly identify the areas where potential risk phenomena for the infrastructure stability are taking place, helping to define a priority for the intervention based also on the analysis of velocity maps. Mille Infrastrutture has been involved by Imperia Province in the case study of monitoring and design of structural maintenance intervention on the Monesi Bridge in Liguria region, where also advanced differential interferometric SAR technique have been applied. The technique developed by Ageos company, a member of Mille Infrastrutture, was applied using ascending and descending Cosmos Skymed SAR dataset in the period between January 2018 and December 2021. The main result is the persistent scatterer mean velocity map. It reports the measured mean velocity along the satellite line of sight upon particular sites. The figures at the right side show the 2 velocity maps carried out using ascending and descending Cosmos Skymed dataset. The combination of the mean velocity map based on the 2 geometries permits to measure the east-west and vertical component of the mean velocity of the persistent scatterer pairs. The yellow square identifies the location of the Monesi Bridge, on which the presence of blue dots show that average velocity of movement with a certain magnitude have been recorded, especially in the east-west direction. These results have been integrated with those deriving from other monitoring techniques, and the working group is currently planning intervention to mitigate the risk of bridge instability. The Enterprises Network Mille Infrastrutture was set up to aggregate best national excellence to increase the safety of transportation infrastructure by implementing a monitoring system that enables decision makers to make informed decisions. The network can immediately deploy key assets of its members in order to increase the effectiveness of monitoring by reducing costs and implementation time. In near future, sharing the circular approach, Mille Infrastrutture will be able to implement research and development models in the field of material processing and monitoring of their state of health to bring down barriers in use of recycled materials also in the construction sector. Thanks a lot for your attention.
Thank you so much, Rafael. And yeah, I'm not seeing any questions for the moment in the chat. So again, for the audience, please do not hesitate and use the chat for your questions. So maybe I can start with an overall question. So because this project, so it's a national a national network. Do you think that this model can also be implemented in or replicated in other countries?
Yes, yes, of course. I add that it is desirable. Each European country could adopt a shared models that takes its cue from the experience of the Italian Enterprises Network Mille Infrastrutture and define community standards to be respected of the static and dynamic monitoring system for a general level. I think that could be desirable.
All right. Okay. So maybe we can just move towards the second speaker, and then we can come back if there are any other questions, and if we have some time left at the end of the session, we can maybe have the other questions. So thanks a lot, and yeah, let's maybe address the other questions later. So now we can move towards our third and last speaker of the day. So I invite Ariana Garcia to take the floor. So she will present. So this time we are focusing on a European project. So we're going from the national level to a European project, and this one is on applications related to GNSS, so satellite navigation, for the transformation of roads and railways, sharing digital infrastructures and safety certifications processes to lower energy consumption and pollution. So Ariana, please go ahead.
Do you see my screen?
Yes, you're all good
Okay.
to go.
Perfect. Good morning, everyone. I'm Arianna Persia from Radio Labs Consortium, that is the coordinator of HELMET project that I'm going to present. This is the agenda of my speech. First of all, we will see how the HELMET project fits into the context of the evolution of transport system and critical infrastructure and application, in particular for the intelligent transportation systems. We will continue with the HELMET project overview and the main details about the HELMET consortium, project goals, motivation and ambition. Then we will see the project workflow with the high-level description of the project activities, and we will move on the description of HELMET architecture design up to the proof of concept activities regarding the demo carried out last month in Rome. Finally, the conclusion with some points of possible future developments. The transport sector is rapidly changing, moving towards increasing the safe and sustainable mobility solution thanks to the new ICT technologies. In this context, particular interest is reserved for the rail context, in which about 57,000 kilometers of line will be equipped with the ERTMS system in the near future, and to the vehicular context, in which vehicles will be increasingly equipped with systems and technologies for assistant driving, up to reach 15% of all new vehicles sold in 2030 fully autonomous. New challenges in these fields will be the resiliency, autonomy, sustainability of the transport systems. At this aim, the GNSS-based priorities will be the use of Galileo constellation in addition to GPS, the multi-sensor technologies with the usage of GNSS information with onboard sensor data like IMU that ensure the resilience of the system, and multimodal augmentation network in order to reach the cost efficiency. In this slide, you can see an overview of the HELMET project that aim to develop satellite navigation technologies for eco-friendly, smart and innovative transport sector that makes the most of digitization and automation. The target applications are mainly two, as you can see from the video: the connected and driverless car and the train management and automation, but also the unmanned aerial vehicle for surveillance roads and railways. This is in order to make the transportation systems more safe, sustainable, accessible, and reliable by optimizing new technological infrastructure. The main goals of the HELMET project are the development of multimodal, multi-sensor integrity monitoring architecture based on GNSS-based solution, introducing high integrity localization determination system both for car and trains, but also with the unmanned aerial vehicles for monitoring. The assessment of the system performance by a proof of concept in a real mobility environment, in this case in Rome, as said before. At last, but very important point, the drawing up of a roadmap for exploitation, standardization and certification of HELMET results, with reference to multimodal augmentation and integrity monitoring network and high integrity and accuracy onboard unit algorithms for rail and roads. Referring to the three main pillars mentioned above, HELMET exploit the enterprise experience and cutting-edge technologies available in the state of art for design the multimodal augmentation network for land transportation and UAV for at high integrity and high accuracy. Provide for the usage of the cost device for high accuracy and integrity algorithms, and aims at the commercialization of GNSS-based solution for land transportation and the certification in road and rail context. The HELMET is a multidisciplinary teams, including a research center and industrial partner. Among the research center, we have Radiolabs, University of Pardubice, and DLR. On the other hand, we have the industrial partner, ITC, Sogei, and Roboato. In this slide, we can see briefly. We can briefly see what are the main work packages of the project, starting from the definition of the requirements of the HELMET platform, passing through the design and development activity up to the demonstration dissemination of result. In this slide, you can see the helmet architecture in which the different infrastructure segments and the mobile onboard units are highlighted with reference to the three different transportation sectors, in particular automotive, rail, and UAV, as well as the GNS multimodal augmentation network of first and second level that serve to ensure the position estimation with high accuracy and high integrity. Specifically, as said before, the helmet multimodal architecture is designed to operate in three different application segments that are railway, automated car, and unmanned aerial vehicle segment. It includes an augmentation subsystem, a communication subsystem, and a multi-sensor onboard subsystem. The augmentation subsystem is the same for the three segments, with different service level based on the network of infrastructure, while the communication and the onboard subsystem are tailored to each application. Going into the details of the architecture, the augmentation subsystem provides the augmentation GNSS integrity messages, while the multimodal multisensory onboard subsystem provides the requirement system information such as position, velocity, and time, but also the attitude of the vehicles. It includes a set of the sensor like the GNSS receiver, IMU, cameras, and LiDAR. There are also a communication subsystem for the interaction among the augmentation network and the onboard unit. And finally, the processing unit that is responsible of integrated measurement from GNSS receiver with other sensor data, but also PVT and protection level estimation. This slide describes in detail the onboard unit architecture, respectively for three different operational contexts, which are railway, roads, and UAV. On this, I go fast, but we mentioned the key aspect of the development of these components that are the use of the GNSS augmentation information, the protection from local GNSS 3, and the multi-sensor approach. All of this to have high accuracy, high integrity, and high availability of the system. Moving on the test phase in a real mobility environment of helmet solution, the joint demo was carried out with RoboAuto and DLR for automotive part and rail part for Radiolab side. In the last month on the Roma Fiumicino highway, with the start and end test at the University of Roma 3 in Rome, in which there is one of the associated laboratories of the Radiolabs consortium. Regarding the demo approach for rail part, since we didn't still have a real train available for helmet project. As Radiolabs, we have simulated the behavior of the train with a vehicle bound to move along a predefined route. Specifically, we have generated a track database with the data recording on the Roma Fiumicino Way, and then we have refined the calculation of PVT with the use of commercial RTK services. Once the track database and the Grant 2 were created, we had other test campaigns on the same road, passing on the same line, to carry out the further acquisition and data processing for real time, but also for processing analysis. As you can see from the figures, for the field test, we have set up the radiolabs vehicles with GNSS antenna and receiver, the onboard unit on PC with the Virgilio simulator running, Virgilio that is a radiolabs onboard unit software, GoPro cameras and 316 camera in order to acquire environmental context data for deep analysis in post-processing phase. The next step will be the use a train running in a real railway for testing the high accuracy and integrity onboard unit. In this slide, however, you can see the equipment of the robo-auto vehicles that was in charge of the development and testing of the onboard unit for automotive part, while at the right, an image of the start of the joint acquisition campaign in Rome. For concluding, the key aspect investigated within the HELMET project concern the design and development of a multimodal augmentation platform for rail, roads and drones, a safety framework for roads, vehicle harmonized with avionic and rail best practice, the multi-sensor onboard unit with advanced integrity monitoring capabilities, including the statistical knowledge of about the local hazard, and finally the contribution to the standardization activity carried out by FTCM Special Committee. Regarding the future development of the project instead, already from the result currently arising from this project, interest is growing in the future possible collaboration to move to the operational phase of the HELMET solution, or to extend its functionalities with other research projects. Potential customers or stakeholders in Italy, like for example ANAS and RFI, has been identified that can represent the end user of the HELMET platform, or collaborating with the HELMET consortium to carry out a further development of architecture toward the operational phase. I conclude my presentation, and I thank you for this opportunity to present the HELMET project in this context. Thank you, Cornel.
Thank you, Arianna, for your presentation. So maybe, so in the chat, because I see that we're running late now, but in the chat I shared the link for the next session, and also there you can find more information about the previous sessions, and also the recording for this session. It will be uploaded, yeah, after we close the event. But so for now, I would maybe just ask you a question, because I don't see a question for now, but so I would just like to ask, from your experience, what are the takeaways from this European collaboration or this project? What are you, for instance, I mean, what are for you the main takeaways from this kind of collaboration, also for the future of the project, and for similar European collaborations? What is the main? What are the main benefits from it?
Yes, it is important that during the HELMET project we have designed, as said before, a platform for different transportation means. It is important in order that the user can be benefit of the improvement of localization determination system for different applications. In this phase of the HELMET, we have designed a development these are HELMET solution, but with other collaboration and new opportunity with the different industry and research center, we can move on to the development and in particular operational phase of the HELMET. this is an important aspect for us. The main objective of the helmet project.
Yeah. Okay, perfect. Thank you. And then I see one final question. So this question is actually for Rafael Santangelo. So it's regarding the synthetic aperture radar data technique for bridge monitoring. So what may be some of the limitations in terms of accuracy? Does the number of satellite images available affect the result, for instance? So Rafael, I don't know if you would like to take the floor again.
Yes. Yes. Surely the interferometric techniques rather from satellite can be used with some limitation. It depends on the exposition of the territory and the infrastructure, and because it depends on the line of sight of the satellite. And also with these techniques, it's possible to detect only slow movements. So not all kind of movements can be detected with the use of this satellite application. And for instance, in the application that we made on Monesi Bridge, we need to have more than 30 images, and the minimum number of images that you need to have depends on the kind of constellation you use. On the same project, we are also testing Sentinel data, and in that case, we need more than 50 images, considering the method that actually we are using. And obviously, satellite application do not replace the other monitoring system. It's a new way to integrate information to identify priority of intervention in particular condition.
Mm-hmm. Yeah, so it's complementary with other techniques, of course. Yeah,
of course.
Yeah. Okay, perfect. So I think we can now close the session. So we have covered more than 1 hour. So I would like just to thank everyone, so all the speakers, and then also the organizations. So also Nereus and Margareta, thank you very much. And then so in the chat, I refer once again to the link for the next session. So there you can register, you can find all the summaries for the previous sessions, and yeah, we hope to see you then in the next session. So that will be by the end of June. So thank you very much, and hope to see you soon.
Thank you very much. Thank you, Cornel. See you soon.
Thank you. Bye.
Thank you, Cornel. Thank you, everyone. Bye-bye.
Thank you. Bye-bye.